So today is section 4.4. We're continuing with shortcuts and showing that triangles are congruent. We're learning two shortcuts today, side angle side and hypotenuse leg. With the side angle side congruence postulate, it says that if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. So again, this is a shortcut so that we do not need to know that all sides are congruent and all corresponding angles are congruent. And for short, it is SAS. It is important to note that it isn't just two sides and some random angle. It does say included angle. I like to say the sandwiched angle. If you look at the example, RS and UV are congruent. They're marked that way. RT and UW are congruent. Again, they're marked that way. Angle R and angle U are congruent, marked that way also. This is a side angle side. We have two sets of sides that are congruent and the angle that is sandwiched. If it was these same two sides, and let's say it was angle S and angle V, that would not be a side angle side relationship because that would not be the angle that is sandwiched. And the same thing with T and V, or T and W. If RS and UV, RT and UW are congruent and it was angle T and angle W, that would not be a side angle side relationship. The other new shortcut for today is hypotenuse leg. Of course, hypotenuse leg will only work for a right triangle. So before you try to use this shortcut, please make sure that you're using it for a right triangle only. That's a common mistake. Don't let that happen to you. So it says if the hypotenuse and a leg of one triangle are congruent to the hypotenuse and leg of another triangle, then the triangles are congruent. So if you look at the picture, again, they are right triangles. So that means that I can use hypotenuse leg. The hypotenuses are congruent. Remember, hypotenuse is directly across from your 90 degrees. So the hypotenuse AB is congruent to hypotenuse DE. And then one of the legs, in this case, AC and DF, those two legs are congruent, which means I can say that these triangles are congruent. If I did not have these two congruent, I could also say leg CB and leg FE are congruent. As long as I have one leg. You have a choice of two different legs, but you must have the hypotenuses as congruent. First two examples, it says, can you show the triangles are congruent using side angle side? Well, as always, they don't always give you every single part of the information. They tell you that MA and AT are congruent, and angle M and angle T are congruent. And the only other thing I can mark that is not already marked is AE is congruent to itself. So looking at what's given to us, this is not a side angle side relationship. It has to be the angle that's sandwiched between the two sides. If I knew that this angle A and this angle A here would be congruent, that would be MAE and TAE, that would be a side angle side relationship. This is not a side angle side relationship. If we wanted to make this a side angle side relationship, we would have to know that TE and ME are congruent, then it would be side angle side. So the answer, can we show it congruent using side angle side? The answer is no. Looking at our next example, can we show this is congruent using side angle side? This is an absolute yes. We have AK and KT is congruent, and DK and SK marked as congruent, and the sandwiched angle between those two sides, angle DKA and angle SKT are congruent. This is definitely a side angle side relationship, which means I'm allowed to write a congruent statement following that same pattern, DKA and SKT. Remember, that order is important. You cannot follow a different order for each of them. You have to follow the same kind of pattern. DKA goes through the one marking, then the two marking. SKT goes through the one marking and then the two marking. So be careful with writing congruent statements. Can I show these triangles are congruent using hypotenuse leg? So first off, I see that they are right triangles, so I can potentially use hypotenuse leg. The next thing I need to look to see if my hypotenuses are congruent and one of the legs are congruent. So here's my hypotenuse OR, which is directly across from my 90 degrees, is congruent to this hypotenuse, which is MN. So the hypotenuse are congruent. And then the only other thing that's not marked is I can use reflexive to say ON is congruent to itself. So if you look at my hypotenuse being congruent and I have a set of legs congruent, yes, I can use hypotenuse leg, which means I'm allowed to say my congruence statement, which is MNO. So I went across my hypotenuse, then my short side, and then RON, again, across the hypotenuse, then the short side. So that's my congruent statement. I also have a proof to work on. We're given that AB and CD are parallel. We also know that AB and CD are congruent. So remember, if they're giving you information, you need it to solve the problem. So as soon as I know lines are parallel, using my chapter 3 information, I can see that I have transversals in there that could create alternate interior, alternate exterior, or some of the other terms that we learned in chapter 3. So keeping that in the back of our mind, starting off with, we need to prove that the two triangles are congruent. So first of all, I see that it's not a hypotenuse leg, so I can't use that triangle or that shortcut. I have two choices. I know side, side, side from our last lesson, or side, angle, side. So that's what's in the back of my mind as I start this proof. So starting off with my given statement, as soon as I know that those two sides are congruent, is parallel. AB is parallel to CD. I can use ABC, which is this angle right here, and DCB, which is this angle, using these two lines being parallel. And always, always mark up your diagram. And using this as a transversal. Hopefully by highlighting that, you can see why ABC and DCB are congruent using alternate interior angles. Remembering back from chapter 3, alternate interior angles says that if the lines are parallel, alternate interior angles are congruent. My next statement is my given statement. I haven't written that yet. It doesn't hurt if you want to put that in step 2 instead of step 3. That's perfectly fine. But again, I know A, B, and CD are congruent because of given statement. I also know that CB is congruent to itself using the reflexive property. And now I do have a side angle side relationship. I have two sets of sides with a sandwiched angle, two sets of sides with a sandwiched angle. I can use side angle side to say that those two triangles are congruent. And again, I recopied that prove statement as my last statement.